Hello, 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 my friends. First of all, I want to apologize a little bit. My notes got a little messed up. We had to change a plan and the whole deal of what's going to be on this unit. So, some of the stuff, if you notice, I don't talk about it at all. That means it's been cut. And some of the stuff that's added has been added. So let's hop to it. Solubility curves. So basically, you're going to get a curve that's going to be like this. There's going to be a line. Okay. Simplest thing in the world. It is super saturated if it's above the line, but it has to say the word dissolved. Okay? If it's on the line, it's saturated. Saturated. Oops, get it right on that line better. And if it's below the line, it's unsaturated. Okay, so solute mass on the line, it's saturated. Solute mass below the line, it's unsaturated. Solute mass is added above the line, it's saturated with excess sitting on the bottom. Only if you are told. So what I'm going to do here is I'm going to highlight this in yellow, and I'm going to include the saturated part. So this part would be saturated, but it can only be called supersaturated if it says dissolved. All right, and that's it. So then let's roll with this. When 90 grams of solute is placed in 100 grams of water at 40, is it saturated, unsaturated, or supersaturated? If it's KNO3. So let's look at 90 grams of solute, 40 degrees. 40 degrees, 90. Boom. Okay. If it's KNO3, that's above. Now it says placed, not dissolved, placed. That's saturated. And NaNO3, there's NaNO3, it's below. It's unsaturated. Oops. If it's Ki, oh, tricky question. I think it's pretty safe to assume that Ki goes on this pattern, right? Let's extrapolate our lines a little bit, and that's still going to be unsat. What if the KNO3 was heated until all the solute dissolves? So what happens? First of all, I'd learn how to spell dissolves. What if the KNO3 was heated until it dissolves? KNO3 was heated until it dissolves, so I would have this much. Then it would become saturated. Then if cooled, it becomes supersaturated. Now, supersaturated really is kind of a super situation. Just because you heat something up and dissolve it and then cool it back down, most of the time what happens is the extra precipitates out. But if you're very careful, very, very quiet, sometimes, but not all the time, it will become supersaturated. Okay. What temperature allows 70 grams to saturate 100 grams of water for NH4Cl? So 70 grams, I'm looking for NH4Cl. Boom, baby. So what temperature is that? I think it's a touch below 90, so I'm going to say 89, 89, 89. Whoops, 80, 80, 80, 80, 89. What solutes are gases on the curve to the right? Okay, so remember, gases are less soluble if the temperature increases. So what does that? Is that the only one that goes down? It looks like it. So NH3, unless I'm missing one. Oh, I'm missing one. HCl. Oh, and SO2. All right. If I only have 50 grams of water and want to saturate it with KClO3 at 80. 80 KClO3. And that is what, 42. But look, I tried to trick you. I tried to trick you. See how I tried to trick you? I have 50 grams of water, not 100 grams of water, 50 grams of water. So 42 would be half as much. 42 and 100 equals x over 50. You can do this any way you want to. We're going to figure out that x is 21 grams. Whew. What if I have 150 grams of water? Still the same deal. 52 over 100 equals x over 150. I'm going to actually bust out my little calculator here for this one. So 42 times 150 divided by 100 is 63 grams in 150 grams of H2O. All right. Now, we've got net ionic equations. All right, so net ionic equations, these are just double replacement reactions, okay? But what's going to happen is we're now only going to focus on precipitates. So we're going to focus on these solubility rules where I've got group 1 ions, NH4s, nitrates. They're always soluble, which means I don't believe in them. I don't believe in you. So what that means is they will never form a precipitate. So whenever I see these things, I just get rid of it right away. Remember, the group 1 ions, if I drew my periodic table, are this first column right here. Not H, but the other ones. Uh-oh. So calcium chloride and sodium sulfate. You see how sodium's a group 1? Okay. So what I'm thinking now is I've got SO4 negative 2, and the only thing it might react with is the positive thing, which is calcium plus 2. So my first thought is calcium plus 2 plus SO4 minus 2 would give me CaSO4 if it's a precipitate. So positive ions, you have the group 1 rule and you have NH4 rule, but otherwise I've got to find my sulfate rule. Most sulfates are soluble. Exceptions are most are soluble. Calcium's an exception. It's a solid. Notice how this is this right here is my net ionic equation. The things that are left over, chloride, right, and sodium, they don't do anything. They just watch. They are called spectator ions. We had a sad basketball game yesterday. I was a spectator. I watched. I did not get to play. I did not get to miss baskets. I did not get to have fouls. I did not get to do disappointing things or the great things that other people did. Sodium phosphate. Sodium's group 1. Nitrate. Always soluble. Makes life easier. So now I got to check PO4 negative 3 plus cobalt plus 2 gives me, all right, that's going to be CO3 PO4 taken twice, maybe. I got to check my phosphate rule. Most phosphates are insoluble unless from above rules, which means this. So insoluble means it's going to be a solid. All right, look at the next one. Na, I hate you, Na. You're doing nothing for me. So I've got Cl is the only thing on this side that's going to form a precipitate, possibly. Cl plus Ba plus 2. So I dropped out the carbonate right away because CO3 negative 2 has no interest in Cl negative 1. Negatives don't like each other. So I didn't even really seriously consider that. So now, remember, the positive one's going to go in front. So my possible one is BaCl2. Barium's not group 1, so I need to check my chloride rules. Most chlorides are soluble, except silver, lead, and mercury. Okay, so barium's not an exception, so it's soluble. Soluble means aqueous, which means ions, which means, I don't write this together. I write it as Ba plus 2 plus Cl minus. So no precipitate. I'm going to write that neater. I'm going to try and write it neater. No precipitate means no reaction. And remember, I guess I should say it again. Aqueous means ions, not silver. All right? Welcome to my little flippy-do mind today. Aqueous means ions. Okay. So, this next one. Nitrates. Nitrates are always soluble. And ammonium, always soluble. So I have Mg plus 2 plus SO4 negative 2. Maybe I get MgSO4 solid. Let's take a look. Sulfates. So magnesium's not group 1. Most sulfates are soluble. Exceptions are mercury, barium, lead. So this isn't an exception. So it's soluble, which means it's aqueous, which means it's ions, which means this guy right here is no reaction. So no reaction. All right, I'm going to get rid of my focus on precipitate writing here. K3PO4 and CuCl2. K, group 1, I don't believe in you. PO4, negative 3. And now negative 3, the only thing it would be interested in would be the positive part here. Because I have a 2 here, I know it's going to be copper plus 2. Oops, got to make it look more coppery and less calcium-y. And that would give me Cu3PO4 2 to balance the charges, right? This 2 plus 2 minus 3 minus 3. So this is plus 2. 3 times 2 is plus 6. Phosphates minus 3. Minus 3 times 2 is minus 6. So that's how it balances. But maybe this reaction doesn't happen. So again, I got rid of it if it was group 1, but it's not. So let's look for a phosphate rule. Here's our phosphate rule again. Phosphates are insoluble unless they're soluble from the above rules, which means group 1. So this is a solid. I've got myself a net. I've got myself a net ionic reaction. And that is it. Solubility rules will always be given to you, so you don't need to sweat memorizing those. You got them last year, but if you didn't write them down, they're here. And after that, I will say toodles.